So why did we talk about the activity series? Because that helps us to predict whether a single replacement reaction occurs. So if the metal that's by itself is more active than the metal that's in the salt, a reaction will occur and the metals will switch places. If it is not more active, then nothing happens. Metals can react with acids. And again, the metal has to be more active than hydrogen for that reaction to occur. Here what happens is the metal is trading places with the hydrogen. We end up with salt, an ionic compound, and hydrogen gas. It's just, you can treat hydrogen as a metal in this situation, saying, well, iron came in by himself, but he was cooler than hydrogen, so he stole hydrogen's state. And hydrogen has to go home by himself. And what does hydrogen do by himself? He's H2. An active metal and water. These form metal hydroxides and hydrogen gas. And the hydrogen gas is flammable, and so when these give off heat, then the hydrogen gas ignites, and then that's just, fun. So a metal plus water, if it's one of those top 6, it will react with water and form a metal hydroxide with hydrogen gas. So here is the activity series up in the corner because we don't want to memorize that. And so we need to write balanced chemical equations for each of these. I'm just going to skip the first one just because I feel like it. So gold metal. Need to get my pen up here. Gold metal is placed in a silver nitrate solution. We don't need to mess around with state symbols. Gold plus silver nitrate. What is the charge on silver ion? +1. And so nitrate is -1. So AgNO3. And we need to predict if this is going to react or not. Here's silver, and there's gold. Nothing's going to happen. No reaction. Cadmium metal in hydrochloric acid, HCl. Is that going to react? There's cadmium, there's hydrogen. Cadmium is more active. So how do we predict what the product's going to be? We're going to replace the hydrogen. So this is H+, I didn't leave enough room here, H+ and Cl-. So the cadmium is going to come in here and displace the hydrogen. So here we're going to get a cadmium ion with chloride ion, and then the hydrogen has to leave by himself. What charge does a cadmium ion have? +2. It's in that little triangle. Aluminum, zinc, silver. Cadmium is under zinc. It's in that row of 2. It's got a 2+ charge. So Cd 2+, so it'll be CdCl2. Is that balanced? No. It's not going to take much, though, is it? Just put a 2 over here. 1 cadmium, 1 cadmium. 2 chlorines, 2 hydrogens, 2 hydrogens, 2 chlorines. A small piece of strontium metal is dropped into water. So those active ones were the top 6. Yeah, something's going to happen. So strontium plus water, what's the product? Metal hydroxide. So it'll be strontium hydroxide. What charge does strontium ion have? 2+. It's on the periodic table. So SrOH2 plus hydrogen. Is it balanced? No. The strontium's okay. How about the oxygen? 1 oxygen, 2 oxygens. Okay, so put a 2 here. That didn't change the strontiums. 4 hydrogens. 2 plus 2 is 4 hydrogens. It's balanced. Any questions? Remembering that an active metal reacts with water to form a metal hydroxide and hydrogen, I consider that to be a very minor issue. Being able to take a written out sentence and write a balanced chemical equation, that is a big deal. Okay? You have to be able to do that.